Hello, everyone. Thanks for joining us today. So this is our fourth session, and Vimal and Dinesh have done previous sessions. Today, I will be handling this session for you. So it will be a bit different, and we are going into a bit more complex stuff. So I will try to go slow, but we have to finish it on time, so I will take care of that as well. Uh, Today's session is some useful stuff we are going to share. We will be sharing construction detailing. We are going to show how you can do tail layout from a zone object, right? So normally we place rooms in Archicad, which is actually the zone, but use that as a boundary and create the tail layout inside. So this is more for construction detailing, right? So you want to know how many number of tiles and all those things. So this is what we are trying to achieve today, right? So before we go in, this is the agenda for today. So we are sharing the link for recordings of session 1, 2, and 3. Later you can check it out. If you have missed it, you can check that, right? And we will be discussing about the assignment as well. And then we will go into the tail layout for by zone, right? We will be showing something like creating a cluster, which allows you to distribute the objects. So end of this session, we will share a cluster for you so that you can try it on your own, right? So that's the plan. So I will take you through that steps. Yeah. Okay, let me get my pointer. Okay. So this is actually the QR code for session 1, 2, and 3. Basically, it's a playlist. You can scan this, and then you can get your videos if you want. And thanks, Vimal, for sharing the link on the chat. So if you guys have any question, you also can post on the chat. Either Vimal or myself will answer. So please feel free to chat with us on the chat window, right? So always ask questions. So that will be interesting to cover, right? So if you have questions, that's interesting to cover. Let me move on. I hope everybody scanned the QR or somebody trying, so it should be okay, right? Okay. So next is the topic. First, I will be showing the assignment. So basically what we have given last assignment is basically you're drawing a spline curve in the plan window. So, and also a spline curve in the section to define the curve of your facade, or it can be a feature wall inside your interior design, right? So you have these two curves to define your wall, which will end up like a 3D object like this, right? So this is the plan curve, right? So this is the plan curve, and this is actually the elevation curve, right? So it is easy for us to draw an elevation. That's why we are drawing an elevation. And we also shared some code with some instructions. So I don't know, maybe you have tried. So if you haven't tried, you can still go back and try, but I will show you after these slides, I will show you in the actual thing, right? So I will show that how it works. For today's session, so this is what I was talking about. So this is the construction detailing part where we will have the rooms, right? So many different rooms we will have. So for each room, construction team have to set up the tail layout. So sometimes people think that Grasshopper, Rhino Grasshopper, or any computational BIM is for complex stuff, but like a fancy design or things like that, but it is not necessary, right? So simple automations can be done as well. So this will be taken through a Grasshopper code, which looks very simple here, right? Like I will take you through. It is not that straightforward and simple, but you can see that how it is done, right? It will put the tiles in your zone. So you can see all the tiles are laid out nicely in an angle you want. From here, you can actually bring it into a schedule, right? So when you see it in the schedule, you can see the total number of tiles. This is actually like we have total 3,223 tiles. Out of it, like 2,915 tiles are full tiles, right? So the rest is actually smaller size or cut by the design, right? So because of the design, it had to be cut. So you have a full detail for construction itself. I know some of you are bringing your design all the way to construction. You will be contributing to that, so it's much easier to get this. But my recommendation is to do it room by room. Don't try to do for the entire project, so it will have some issues on the performance because of the code, right? So it will have some issues. Okay, so let's go back to the assignment part. I will just run through this assignment part quickly, then we will go through the today's session, right? So let me close this, minimize this, so you can see. Okay, so this is the facade, right? So everything is, these panels are created as a marf. So in Archicad, where it comes from is actually from the plan view. If you see, this is actually the curve I have, right? So this is the curve I have. And if I go to the elevation, so this is in the elevation, this is the curve I have, right? So let me do it slowly. So yeah, you can see this curve, right? So all these panels follow the same curvature. So it can be used for a feature wall, or it can be used for a facade, right? So either way is fine. So if I go to the plan and if I try to change the curve, so I will take this and I will change it a little bit. I don't want to make too much change, right? So I will send the changes to Grasshopper code. So you can see it will get rerun and the facades get updated, right? So this is what it will do. So once you have this code as a recipe, you always can reuse it and you can get it, right? So how it is done, let me show it. Okay, let me show that in the Rhino part. Okay, so this is actually the Rhino code I have, and let me make it full screen so I can show you what I have done, right? So this is actually the first curve. I'm getting it from Archicad, right? So this is the first curve. I'm getting it from Archicad. Let me see. Yeah, so I don't want to, it is running, so it's okay. So I'm not going to do every step. I'm not going to place everything. So we have shared a screenshot with you. So you can see here, connect the first thing. So you can right click here and you can set one spline and you can connect it with Archicad, right? So you can connect it with Archicad, the spline itself in the plan. And this one, I'm connecting it with the elevation. So we have two of that. So it is also a good practice to convert that into a grasshopper curve. That's why I'm doing here. So anyway, it is coming as a curve. I will just make sure it is done this way, so I can send it to different objects or different components from there, right? So this component is to get the endpoints of this curve, right? So I want to get the endpoints of this curve. So remember, this is the plan, right? So we are working on the plan curve. So we are getting the endpoints of the curve. In case you want to know where is this in the Grasshopper menu, if you press Control and alternate key and click on it, it tells you exactly where I'm getting this component from, right? So if we share any Grasshopper code, you can try to read it quite easily, right? So you can see that. So once I get the endpoints, right? So I'm passing the start point to 1, and the endpoint I'm doing a deconstruction, right? So I'm getting the XYZ of the endpoint, and I'm passing the start point to the move command, right? So what I'm doing within this particular group, so this particular group, what I'm doing here is to construct a new point based on the width of the panel, right? So basically the panel has a width, right? If I go to Archicad, you can see, right? So this is actually the width from here to here, right? So this is the width. Let me measure it so that you can see, right? So maybe this is a start point. You can see this is actually the width of the, is about 2 meters, right? So that's a width of the panel I'm taking. So let me go back to, so that's a 2 meter coming from here, right? So this is a slider. And if you want to set this 2 meter, the distance for the movement, basically you pass a vector. So the vector is y vector. So if you want to understand why it is y vector, if I go back to Archicad, so this is the x direction and this is the y direction. So I'm using a y vector for this, right? And if I pass any value to it, it will multiply the vector by this value. Vector is nothing but a direction without any dimension to it. If you want to add a dimension, you just multiply by the factor, right? So you will see that, and you are passing that to the motion, right? So you are passing that into the translation, right? So that what it will do is it will get this point, the start point, and move it to that location, right? So if I select it here, it should show in Rhino. Where is it, right? So if I select it, I can see that here. So let me see. Yeah. So it should be here. Okay. So this is a movement. So I can. So the preview is on. So let me see. Yeah, this is the curve, and this is, I'm getting the start point of it, and I'm getting the point. I think it's overlapping too many objects. It should be somewhere here, right? So this should be the point actually. So I'm not going to spend time on it. I'll go in, right? So if you see here, this I'm getting the XYZ value of it, and I'm passing the X value of the endpoint to this, and the Z value to the Z value of this point. I'm constructing a new point on the new location, and I'm passing this Y to this Y value. So when I pass this geometry, so if you see this geometry is having this value, it has 0.51 and 10.69, right? So if I see this Y value here, it will just take the 10.70, the one, right? So it will round it off. So it will just get that value. So if I check this point, it will be on the new location, and I can pass this to form a new line, right? So I have this 2 points. I'm passing this point and this point to form a new line in here. So if you see here, it is highlighted in green. So I'm passing and creating the back of the panel. So this is the back line, right? So I'm creating it. So that part is done. Now it's this other curve, right? So the vertical curve. So we get this curve, and we need to rotate this curve, right? So this curve is actually on this location. So you can see here, it comes on this location, right? So if I see it, I'm actually rotating it. So let me see it in the 3D. So right, let me choose 3D view, or I will show the other side. Let me sit. You can see this is actually the curve, right? So this is the rotating part. So I'm just holding the Y axis and rotating it up. So I will get this, and I will rotate it again to the vertical side, right? So I will rotate it again to the vertical side. So this is the second rotation I'm making. So now if you can see, it will come in on the vertical side, right? So you can see the vertical side. So this is the curve I have already created. Okay. So now I got this new curve, and I'm getting the start point and end point of this, same as what I did on the other curve. So after getting the start point and end point, I'm using the point we get on this level here. So let me see, this is the line, right? So for this line itself, we are actually trying to construct some information. So we are dividing the curve into 27 numbers. So if I select this here, so it will tell me all the individual points in between. So we are basically dividing the curve, right? Let me minimize and show it to you. You can see there's little dots here. So all these are highlighted. You can see that, right? So we are actually dividing it, how many number of panels we want to have, right? So we are doing that. So once I do that, okay, let me go back. Okay, so I'm dividing it and getting it projected to the horizontal line in the back. So I'm going to draw a straight line. So I'm projecting it to the horizontal line in the back. So if I see here, it goes in here, this line here. So you can see these dots. These are the ones I'm getting projected there, right? So let me zoom out and show it to you. Okay. So if I see this is to project the curve point, right? So this is to project the curve point. So all the points are projected here. So you will see these dots here, right? So that's done. So now we have this curve, and we are using that to get the vector. So the vector is basically the distance between the start point and this point. The curve is located at a different location, right? So I want to get the angle. So let me show you something. So here I will just show this part. Vector display. I'll show you what it is actually, right? So we can actually visualize the vector. So I take this vector, I put it here, right? And the anchor point is actually the starting point of this curve, right? Starting point of this curve. I will take that. I will pass it to this anchor point. So you can see what happens, right? So you see this is my curve, right? The vertical curve, the one in the elevation. So this is the location I have it. So basically I'm projecting this curve to each of this point. So I'm basically moving the curve to all these points. So when I say move, it will copy in Grasshopper, right? So when I say move, it will copy in Grasshopper. So this display I will delete. This is not required. So I will delete it. Okay, let me close this. Okay. So now that we have these vectors done, right? So you can see I'm passing the movement, right? So this is actually the movement part. So I'm moving the vertical curve to each of this place. So out of this, we are generating, again, getting the start point and end point of each of this curve, right? So along this point, each of this curve, we are getting the start point and end point. Okay, so for this geometry, so this is in the back. So you can see those things here. In the back, and we are getting the geometry of it and passing it to these points here. So basically this curve, this curve, this curve, and this curve will form one rectangular shape, right? So let me see whether I can show it. So let me make this perspective bigger. So if I see this, if I select this one, so you can see these are this is a curve and it is on the other side, right? So you can see it takes all these points and draws a curve, right? So if I pick this, that is actually the surface. So it creates a surface on each of this plane, right? So that's the part it comes out. And finally, so I'm extruding it by the thickness. So I'm sending into Archicad as a morph. So that's what we are getting in Archicad, which is actually these panels, right? So we can see it is selected here. So when I select it, it is selected here, right? So once you have this recipe, it's easy for you to reuse it all the time, right? Is it good? If you have any questions, please put it on the chat. We can share this code with you. So in case it is difficult for you to digest or get anything, so we can actually share this code with you, right? So don't worry about it. Okay. So let me move on to the next one, which is the tile, right? So I need to open another file, break the connection. And you can see here, this is what I got from Archicad. This is actually the tiles already coming in from Grasshopper. But what I have here is just the input is just a zone, right? So if I say this, you can select it. You can see this outline of the zone, right? So any shape is fine, right? It works with the curve also. I have tested. So if you see here, that is actually the preview is shown here, right? So I have made this whole thing as a cluster. So this is what you are seeing here. So why we do this is because if I want to share with somebody, if I want to share with my users or anyone, right? So I can just send the cluster to them so they can actually use it. It's like creating a bit of code by yourself, or recipe. You can just make it as one whole object, encapsulate it. So people can use it straight away, right? So the first input is actually coming from the zone. I select from Archicad. So we might have shown this before. So you can right click on it and you can select zone surface. You can get many of the information from the zone, right? So you can use any of this information and you can get the details out of it. But one good thing what I want is just the perimeter. So I want the polygon, so I can take it from here. I'll use it here, right? Zone perimeter. And I'm also getting a insertion point. You can see here, this is actually the insertion point. So I'm getting it. And this is actually the reference point, right? Then it comes with tail orientation. Tail size is like a 300 by 600, right? So you can see that here. And also the grout size, right? So construction details, you need to have this grout size, you need that. And this is the tail thickness, right? So I'm using just a panel here to do it, right? So the panel, instead of using the slider, we also can use the panel to get the input, right? So you can give the input with the panel. And sometimes the tail comes with the grout gap. So the tail is offset from the starting point. So if it happens, you can use this to control that. So that's why we have this additional things here, right? So the direction you can set either 1 or -1. So it goes either forward or backward. That's it, right? So just pass it like 1 or -1, right? So end of the day, it outputs a set of geometry, and these geometries can be passed to the morph tool in Archicad, and you can actually place the morphs, right? So the morph setting, I'm using the building material. I'm also passing the layer, and this will set false, right? So that it will not keep sending the changes whatever we are making. So we can actually do that. So if we have done this, so if I double click on it, it will open up the entire cluster for me. Hope it doesn't crash. So let's see what happens. Yeah. So you can see this is what I have inside the cluster. So I made it a bit more clearer. So we will share this cluster with you guys. You don't need to write everything from scratch. You can try to read this and use it. So we are planning to share this. So you can see this is the cluster input. So the first one is the cluster input, right? So this is a boundary, this is a reference point, this is actually the size and angle. Then you have the rest of the information below, right? So it's actually mapping exactly to the cluster. If you see the cluster, you can see that, right? So temporarily, I'm using it's like a temporary storage. So instead of having multiple inputs, I'm using this to control the number of inputs the user have to give. So maybe I'm using this point many times. You can see here I'm using it 2 times here. So if I use this way, the user need to input only once, right? So they will not see multiple input in the cluster. So that's the reason why I'm using this part. So I use this to control it. The first block here, I'm creating a single cell. So this is actually the size of a tail, right? 300 by 600 it will make. So this is the object which makes the tile. So if I right click and enable the preview, you can see that in Grasshopper, right? So you can see that in the Rhino side. So I will show everything on the Rhino side before we bring it in there, right? So let me off this preview. So I can right click and off the preview, right? So I can do that. At the same time, there is actually, I'm also getting the curve, the boundary of the zone, and I'm actually exploding it, right? So I'm using it below. I will come back to it later. So let's look at the tail, right? So this is the part where we are actually adjusting the grout offset. So you remember we were talking about sometimes it starts with the grout. We want to offset it. So we are actually doing this control here, right? So basically I'm using the direction. So positive or negative, I'm using that. And here, what is the amount, right? So X 0.5, right? So the grout is a 0.5 size. And this is actually the move command. I'm moving it. And if people want to say, yes, I want to move it, it will take the value from 0 or the other way, right? So it's like a conditional statement. So based on the yes or no. So the first one, currently you can see 1 means that the gate have to take the 1, right? So 1 or 0, it will take it. And it will pass the geometry to the next component. So this is for the X direction offset, and this is for the Y direction offset, right? So I'm doing this offset 2 offsets here. to get the grouting adjustment done, right? So this is the part. This is all added later stage. After I solve it, I need to add this, so you can see that. And here on the bottom part, I'm adding a grout tile size. So this is actually the tile size. I'm adding the 0.5. So because every offset, we want to make it with the tile size plus the grout, right? So that's the reason I'm adding it. So you can see that, and the result is coming here. So one is X and Y, right? So remember X and Y. So when you go here, this is the part quite interesting. So if you see, I exploded the boundary of the zone, right? So earlier I exploded the boundary of the zone, and I'm passing it to here to get the start point and end point of each of that. And I'm getting the distance between the start point and end point, right? So what I'm getting here is to find out the distance, how far I need to offset. So why I do this, right? So if you look at it, so my thing is here. So let me draw something to show you. So I'm starting somewhere here, but the tail have to be covered maybe a bigger area, right? So it have to go very big area. So I need to know how far I need to offset the tails actually. So that's the reason why I'm doing this. So for this, basically the distance is calculated from the reference point, the first one reference point, and to the start point of each of this curve. These curves are coming from the zone boundary. So I'm getting the start point and I'm getting the distance for each of them. And this particular tool here creates a domain, so which I can see where it comes from. If you want to know where it is coming from, I'm using it from the math. So basically what it checks is the list of values, the distance here, and it creates the maximum and minimum, right? So this is actually maximum and minimum, it will get it. So it checks everything and it will see what is 0 is the minimum, 14 point something is the maximum, right? So after that, I'm getting the maximum because I want to know the maximum distance, so that I'm getting it from here, 14, right? So I'm getting it from here. Then the next step is to get the number of tiles in X direction and Y direction. So for that, basically I'm dividing the value, right, the 14 with the tile size. So when I do that, I get the number of tiles I need to cover the X direction and Y direction, right? So I'm rounding it off. So when I round it off, I will get the number of tiles like 42 and 23, right? So I'm getting the number of tiles I need to offset or I need to copy, right? So that's done. And if you move on here, so multiply the number of tiles. So we are just multiplying it to get the offset distance, how far we need to go, right? So that need to be done. So I'm basically multiplying the value. Again, it's like instead of dividing, we are doing multiply so that we can get the total distance offset, right? So that's we are passing in here 14.7 and this is 14.95, right? So both directions. And another round off I'm doing here. So this is actually to, because when I say I'm starting here, right? So when I start here, if I offset this way, so I cannot just offset this way one way, right? So it have to be both ways. So it have to be double time. So this round off, I'm multiplying it by 2. So you can see here, I'm passing it 41. But when I get here, I'm getting it 2 times 84, right? So how I get this, you can see when I right click on this, sorry, when I click on it, expressions, I can add an expression, which is actually like, if I'm getting X, multiply it by 2, right? So when I commit this, so I will get double the time. So I need to offset it 2 times on both sides so that I will get covered the entire space actually, right? So that's the idea. So now I go back to this tiles here. So this is a part where we are rotating the cell to follow the angle the user want. So let me show you the preview so that you can see. So you can see this preview, right? So the tile is already rotated. Initial tile is this one, right? So initially this is the tile. So this is the tile we have. Now we rotate to the angle the user gave, right? So you can see that rotation here. Okay, so once it is rotated, the next step is to let me switch off the previews so that it doesn't confuse. Okay, so then I move on to here and I move this by the size of the vector, right? So I move it by the size of the vector, the direction. So again, the angle is coming from the user, so 45 degree, and I'm getting the angle how far we need to move, right? So I'm getting the angle between two vectors. So once I get this, I multiply that by the values, and I'm moving the object to that distance, right? So if I set a preview for this, so you should be able to see it. You can see I move it far away here, right? So this zone is here, I'm moving it here, right? So that's the movement. So because of the maximum distance times 2 and all, you will get that, yeah. So once we do that, we had to rotate it again, right, by the y unit vector to arrange the angle about thing, right? So you have to get the angle again. So the same thing, I'm kind of like repeating this, whatever we do in the X, we are doing it for the Y as well, right? So if I see this, I'm passing the same geometry. This first one is done in X, the second one is done in Y, right? So I'm right clicking here and I say preview. So now you can see it is here, right? So it's moved far away, right? So let me switch off the preview. So then we have to array them in X direction and Y direction. So once we have done this, I'm going to array this. This is actually the array command, linear array. So for this, I need to get few information, right? The geometry. So the next one is the direction. So the direction comes from this one, right? So the direction is actually the distance, right? So you can see the angle. So 84 comes in, so it multiplies to that. And this one is the, yeah, sorry, this one is the number. This angle is coming from here, sorry, right? You can see here direction. So that comes from this particular item. So I'm multiplying the angle and passing it to here. So I get this array. So when I right click here and show the preview, you can see, so that covers this whole space, right? So it's across here, right? So I'll do that and I will go to the next level. Again, I need to do the array of this geometry in the other direction. So if I right click on this and show the preview, so let me show the preview. So it covers the entire space, you can see. So I started somewhere here, move the cell to here, right? Then move it to here, then do an array this way and do an array this way. So you can get the entire space covered with the tile array, right? So basically everything is placed, so it has everything, right? So now that we have to do some trimming, right? So we are interested only in this space. We want to have the tiles only within this. So we are going to use this object to trim it, right? So we are going to use this region intersection to trim the geometry, right? So for that, we are actually passing the object. So before passing the object, what we had to do is both the zone and the tiles have to be in the same height. That's what we are trying to do here. So we are getting the center point of the zone, getting the Z value of it and moving it to that height. So basically I'm moving all the tiles to that particular height. So you can see here. So if I see this one preview in the, you can see the tiles are not here, right? So you can see it is below. So, and if I show this preview, it will be a bit up, right? Let me see, I can show that preview. I think I should switch off this. I think in my case, the zone is on the 0 level, so it doesn't have any problem. But it happens sometimes if the zone is offset, you will have that problem, right? So you have to do an offset for that. That's why I'm doing it, right? So you can see the offset is handling that. If it is not in the same level, this component will not work, right? So that's why I'm doing this. So once this is done, this particular thing works fine, right? So you can see that extrusion is done. It creates surfaces. So let me show the preview of this. So it creates this flat. It doesn't have any thickness, right? So these are the surfaces. and I'm actually passing that to the extrusion component, then I'm getting the extrusion out of it, right? So you can see the thickness now, right? So this thickness is coming from here. This wire is currently hidden, so it is actually coming from the thickness on this one, right? So the user input, so the thickness is coming from there. Finally, this will do a output from the cluster, right? So we don't know what it does. It does the output from the cluster. It's like a code inside code, right? So let me close this. I will discard and close. Yeah. So I will see this. This is the output coming from here. Then I pass it. So, but if you are a user, if I pass you this, so it is very clear for you what are the things to pass and what you will get outside, right? So that keeps everything hidden from you, right? So whatever we have done inside the cluster, it will be hidden from you, right? So you can see that. Just we have about 10 more minutes, I think. So, but we will take a quick one. I will show you how to do a cluster. Then we will open up for any Q&A, right? Okay. So I'm going to draw something, right? I'm going to draw a polyline. This is what caused the problem earlier, crashing. So let me draw a polyline. Okay, I have this. Imagine this polyline is my travel distance in my model, right? So something simple can be done as well. So I can see this line is the travel distance I'm having it. So what I can do in Grasshopper is I can create a node for it to collect it. So this is actually coming from, right? So let me do a polygon. Okay, let me see the Archicad. Extract polygon. So I will say collect one, right? So I will say set one in Archicad, and I will pick up this polyline. So now I got the polyline, right? So I have the curve. So for this curve, I want to get the distance, right? So I want to get the distance. So I can just say curve length. I can get a length. So I know this length, right? 38 point something. But what is useful for me is if I put that in Archicad, right? So otherwise it is not useful for me. So how I can put that in Archicad is you can actually put a text in Archicad, right? So I can pass this to a text, right? So there's actually a text object. So I can pass this to a text, right? But it is not collecting all the information necessary. It also need to know where your insertion point is, right? So for this insertion point, I want to place it in the middle of it. So what I can do is I can get the midpoint of a curve, right? Curve middle. So this will allow me to get the midpoint of it, and I can pass it to this, right? So that's done. And the next one is the 2D viewpoint. So for any 2D object, you have to give a 2D viewpoint. So that is also coming from my polyline, right? So it's easy for me. So I take this and pass it to here, right? So now the text is already placed. You can see it shows in Rhino as well. And if I go to Archicad, I should be able to see that. Let me see. Yeah. So you can see it places here as well. So I get the total length of it, right? So quite easy in a way. So once you have this recipe, you can reuse it, right? So what I can do more is I want to get a bit more interesting. So I want to explore this curve, right? I will explore this curve. Then I will pass this curve to here. So I will have multiple curves, right? So 3 curves I have it now, and I will make a copy of it, right? I will make a copy of it, right? Then I will also make a copy of these 2, right? I select both of them, I move it down, I make a copy of these 2, right? Then I will place these things, right? So these are the vertices, these are the curves. So I will pass this to here, and I pass this to here, and I'll pass here this one to the text, right? Then this one to the insertion point. Okay, so you can see I'm changing that, and you can see all the green color text already come in, right? So you can see those things. Okay, so a bit more to do is basically like, yeah, you can get a curve and you can pass it, right? So I'm not going to go through all the details. So I have prepared a bit more, like getting the angle and rotating the text and all those things. So maybe I will show a quick one, then you guys can try later. So I can get a text settings, right? So I will go here. There is actually a text settings. So I can use that, right? Then I can set an angle input thing, right? So I can just go to the pattern and I can say I want to input the angle. So for this, I can go inside and I can set the range, right? So it's 360 and I want to set the value to say 90. And I want to set, sorry, the one I need to set this first, 360 also. And this one is 90 again. So once I have this, I pass this angle to here, right? So this angle of the text. Then I can give other settings as well, right? So I can give it, I can pass this to the settings here, right? So you can see now the text is rotated, right? The text is actually rotated. And we can also move the text location if I want. I'm not going to do that now because of the time constraint. So what I can do is I will move this. I'm going to show you how to create a cluster. So how do I create this kind of thing and distribute to people, right? So I select this. So I select this one and I will go to my edit menu and there's this cluster, right? So if I say cluster, you can see everything I selected will be added this way, right? So it is like you're passing this information and it will output this information. So if I double click on it, you can see these are the inputs, right? So these are the inputs, comes out. So you can arrange it nicely and you know what it is giving out, right? So you can do this way. So your code will be clean and you can easily pass it to people, right? So I will save and close. So you can see, and all these are the orders. So in case you want to keep the angle below. So if you want to keep the angle to the bottom, so just go inside here and you can actually move it down here. So if I close it, save and close it, so you can see the angle become below here, right? So you can reorder the things and you can change the icon for it, edit cluster, sorry, close it. No, so you can set the properties, you can go to the properties, then you can actually change the icons of it, the color of it. So if I click on it, you have an option to pick the cluster icons. So it can be anything, right? So you can choose anything, then it will become your icon, right? So this way you can create a component and you can distribute to people quite easily. So end of the day, I try to do two things here. So it is not only 3D things, you also can get the length, all these things. So if I change this, if I change it, it should send changes. You can see it should update it, right? So that's all I have for today. Unfortunately, my thing crashed and yeah, so I couldn't able to cover everything what I planned for this part, but yeah, this is how I created the cluster and easy for me to distribute to everyone. All right. Okay, so let me go back to my slides. Okay, so we have seen the assignment. Hope you will try. So Vimal have already sent an email. So with all the details, you can try, right? So, and the tail layout, what we are planning to do is to share this cluster with you. So when you get this cluster, you will be able to reproduce what I'm doing, except the crash, right? So maybe the crash will not happen because we are going to give only the cluster. So you create a new file and you try to do that, right? So let's see that. So yeah, sorry, one part I missed out is to create this schedule. I will show you how I did it quickly. Then we will end this session. Yeah. So yeah, if you want to follow us on the social media, you can actually follow us on the social media. All right. So I think I have drawn something. Let me remove it. It's all drawings. Okay. So these are the social media links for us. All right. Okay. And we have created a channel, created a playlist. So we will add this today's session also in that. You can see from there, right? So this is my email. You can contact me. And if you have any questions, you can actually post it on the thing, or you can ask in our thing, right? So you can just open your mic, you can ask as well, right? So you can see that. So just a quick one, I will show the schedule part, right? So let me go back to Archicad. So let me open another file. Okay, let me save this in case anything. This is a bigger room. I tried on a different size and different shapes. So this is a bit bigger room, right? And I have created a property to translate or round off the numbers, right? So or round off the area. So let me show you the property. Then I'll show you the schedule. Hmm. Okay, so this is actually the schedule I have. So you can see this particular item here is actually a property, right? So I have created a property to round off the tile size. So there are actually 2915 full tiles in my model, and total number of tiles I have is 3223, right? So in case if I want to know what is this tile, where is this tile, I will check on the plan. I will just select it on the plan. I will be able to see it, right? So it got maybe trimmed off in a corner. So that's how it comes out. So you can see that's on the edge of the room and it got trimmed off a bit. That's why the area is smaller. So in order for me to find out all the full tiles, I need to use the area, right? So the area, I'm creating it as a property. So you can see here, I have this property, surface area. So this is a property I created and I'm using this expression in Archicad to create it. So if I see this, let me make it a bit bigger, right? So basically this is this is a value. So I'm doing a round off and I'm converting a string to number, and also taking out the units for the area. So I'm getting the net area of the MARF, and I'm just converting it as a normal string. And from the string, I am converting it as a number again. Then I'm rounding it off. So this is what I'm doing. So then I get the values. So using this, I'm getting the full tiles easily, right? So you can list down the schedule quite nicely, and you know exactly how many full tiles you need for your particular room, right? So this can be done for a slab. This can be done for a wall. Room is one example we are showing, but it can be done for other things as well. Yeah. So thank you very much. Let's go back to the Q&A. Yeah. So any questions so far? I see. I see some help from all your. Thanks for all the help, Ayan and Janik. Right. So yeah. So especially when you're using an online sharing session, Grasshopper is a bit more unstable. But today is really because of what Janik mentioned, right? So it is the red nodes. So I'm trying to run a Grasshopper connection without the components in Archicad. The Archicad I didn't save, so the components are there, not there. So there's a reason it was crashing. It is my mistake. So yeah, it is not because of Archicad or Grasshopper. It is because I deleted the lines. It is not there, and it started crashing. So I was trying out earlier before this session, so that was happened. Yeah. Okay. Any other questions from the team? Oh. So we will share this cluster, so you can try it on your own. So you can explore it and you can reuse it for your work. Yeah.